Right. Then let's take and understand principles of nomenclature. What the principle we have take for giving name or for organic compounds, there are certain rules. Then before we understand what is word root, suffixes, prefixes, substitutions, how we are given the priority for those, all those things we learnt, we discussed. Now let us understand principles of nomenclature. So there are six principles for nomenclature. The first one is giving number for carbon atoms. Numbering carbon atoms. How we have to give the number to the carbon atoms? 1, 2, 3, 4, 5 like that. The first point we have to see. We can number the carbon atoms from left to right or right to left. Means we can count the number of carbon atoms in the compound from left to right and right to left. So what is that use? So that some of the numbers indicating the positions of substituents and functional group should be minimum possible. Should be minimum possible. So any carbon atom has substituents. For that carbon atoms we need to give the minimum number or the smallest number. Right? Then second point, the functional group carbon should be given the lowest number even if it is does not obey rule 1. What is the rule 1? What is the rule 1? Some of the numbers indicating the positions of substituents and functional groups should be minimum possible. Minimum possible means if the organic compound has functional group directly to the carbon or the carbon atom which has functional group, for that number we always give number 1. That carbon taken as number 1. Then the carbon atoms of chain terminating functional group like aldehyde, CHO, COOH or ketone groups should be given always number 1 if does not obey rules 1 and 2. So if the compound has functional group, that functional group contains carbon atom, so we need to give the first priority to it. So let us discuss with some examples. Right? We can count, for example, 1. For example, take a compound CH2, 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 CH2. How many carbons? 1, 2, 3, 4. So wood root bute. Single bonds are there. 1, A. Unsaturation A. End with single compound of the A. Butane. So how we give the number 1, 2, 3, 4 or from left to right. 1, 2, 3, 4. Right to left. So this compound has no branches, no substituents. No branches or no substituents. So that's why what we have to do? We give the number from left to right or right to left. No problem. But if the compound has substituents, for example, take chlorine, here also chlorine. Chlorine and chlorine. Right? Here increase the one more compound. CH2, CH3. So give the number 1, 2, 3, 4, 5. From left to right, you can given 1, 2, 3, 4, 5. So when we count the carbon number of carbon or counting the carbon from left to right, 1, 2, 3, 4, 5 means when we count the number of carbon atoms from left to right, second carbon and third carbon as substituents. When we count from right to left, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When we count the numbers, carbon atoms from right to left, 1, 2, 3, 4, 5. So third carbon and fourth carbon has substituents. When we count from left to right, second and third carbon has substituents. When we count from right to left, right to left, third and fourth carbon has substituents. So what we have to do? So sum of the numbers indicating the positions of substituents and the functional group should be minimum possible. Means the carbon atoms which have the substituents must be have the lowest possible number. The lowest possible number. So in which side get the lowest possible numbers? When we count from left to right, then the name is 1, 2, 3, 4. So 1, 2, 3, 4, 5. So 5 pent AN. So second carbon and third carbon has substituents. So second carbon comma third carbon has substituents. What are the substituents here? Chloro. How many chlorines are there? 2. 1, 2. So we can write di. 2 substituents in that, then we can write di. So this name is 2, 3 dichloro-pentane. Then when we count from right to left, third carbon and fourth carbon has substituents 3, 4. How many are there? 2. Di. What is the substituents? Chloro. How many carbon atoms? 1, 2, 3, 4, 5. Pentane. 3, 4 dichloropentane. 2, 3 dichloropentane. So 3, 4 dichloropentane is the wrong one. 2, 3 dichloropentane is the right one, because of the carbon which has substituents must have the lowest possible number. Must be minimum possible number. Minimum lowest number should be there. Second, the functional group carbon should be given the lowest number even if it does not obey the rule 1. Even it does not obey the rule 1. So the substituents carbon atoms must get the lowest minimum possible. That is the rule 1. If the carbon compound or the organic compound has functional group, means the functional group carbon should be given the lowest number. For example, CH3, CH2, CH2, OH, after we have taken OH, then we can take chlorine also we can take it. For example, we can take CH2. functional group or whatever. So we would going to take, no problem. You can take chlorine, CH, chlorine. So count the numbers. Count the carbon atoms. 1, 2, 3. 1, 2, 3. From left to right, 1, 1, 2, 3. From right to left also 1, 2, 3. But the functional group carbon should be given the lowest number. So which carbon atom has? So in this compound, this carbon atom has functional group. Functional group. So we must give the lowest number for this carbon. So 1, 2, 3. 1, 2, 3. If it is one more substitution, but the priority is this one. 1, 2, 3. Because of the functional group contains carbon. The functional group carbon should be given the lowest number even if it does not obey the rule 1. Right. Then, similarly, if you take one more carbon, for example, here CH3, CH2 or CH. Here one more is there, like this. 1, 2, 3, 4 carbons. But do not obey the rule in this one. 1, 2, 3, 4. 1, 2, 3, 4. This carbon has functional group. So this is the lowest possible number. Is the lowest possible number. Then third, the carbon atoms of chain terminating functional group like aldehydes or carboxylic acid group should be given always number 1 if does not obey the rules 1 and 2. Rule 1 and 2. For example, CH3, CH2, CH2, COOH. CH3, CH2, CH2, CH3, CH2, CH2, COOH. This is the functional group. The functional group has the carbon in the chain or in the compound. This should be give the number 1, 2, 3, 4. 1, 2, 3, 4. Even if it is has any substitutions. Even the other carbon atoms has any substituents, also give the number 1 for this. Means the carbon atoms of chain terminating functional group. The organic compound has functional group. In that functional group, if the functional group has carbon, for that carbon you give the number 1. Always give number 1 even does not obey the rule 1 and rule 2. Rule 1 and rule 2. If it has CHCl, right? Then if this carbon has COH, this is the first one. Second, third, fourth, fifth. Second, third, fourth and fifth. This is the first carbon because it contains carbon directly in the chain. In the main compound. The main compound, the functional group has carbon, should give always number 1. always number. So 1, 2, 3, 4. 4 carbons bute carboxylic group. OIC acid. Butanoic acid. Butanoic acid. This is 1, 2, 3, 4. 1, 2, 3, 4. 4 bute. Chlorine substitution is chlorobutane. Chlorobutane. Then next one, longest chain rule. Longest chain rule. Select the longest longest continuous chain of carbon atom, which known as parent chain or principal chain. All other carbon atom constituents in the chain are branched chains or side chains. Longest chain. So CH3, CH2, CH, CH, CH2, CH2, CH3. Here CH3, CH3. Right? Always select a long chain. Give the numbers like this: 1, 2, 3, 4, 5, 6, 7. This is the parent hydrocarbon or parent chain or main chain or principal chain. Principal chain, main parent compound chain. Or give 1, 2, 3, 4, 5, 6, 7. Rule 1. Then the remaining these carbons are considered as side chains or branched chains. Branched chain. So carbon. So this is the main chain. This is the main chain or parent chain or principal chain. Then these two are the branches or side chain. Then lowest number rule. Lowest number rule. What is this lowest number rule? The carbon compound which contains only one substituent number, the carbon in which way the carbon atom carrying the substituent get the lowest number. The first one like that. Here the first one taking two substituents. Here take only one. For example, CH3, CH2, CH, CH2, CH2, CH3. Here it has only one substitution. So count the carbon atoms from left to right and right to left. Left to right 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then count from right to left. 1, 2, 3, 4, 5, 6. If the carbon compound or the main longest chain or the main chain has only one substitution, so the carbon which has substitution should give the should get lowest number rule. So from left to right 1, 2, 3. 1, 2, 3. So you can write 3 chloro. How many carbons? 1, 2, 3, 4, 5, 6 heads. Single bonds. And saturation and A. 3 chlorohexane. If you count from right to left 1, 2, 3, 4, 5, 6. When we count from right to left, the substituent for fourth carbon. Fourth carbon. So according to lowest number rule, the carbon which has substitution should get the lowest number. So 1, 2, 3, 4 okay. So then we cannot write it as 4-chlorohexane. 4-chlorohexane. We cannot write 4-chlorohexane. Okay, write 3-chlorohexane because of this carbon has lowest number. The substituted carbon get the lowest number. So this rule is called as lowest number rule. Then coming to lowest sum rule. If two or more substituents in the carbon compounds, the parent chain is numbered from the end, which gives the lowest sum rule of the more substituent carbon. Two or more substituents are there. A parent carbon compound has two or more substituents in the carbon compounds. The parent chain is numbered from the end, which gives the lowest sum of more substituents atom. Right. So let's take the example. CH3, CH2, CH, CH3, CH, CH3, CH. Okay, not visible. Then just I adjust that video. CH, CH3, CH. Like this. How many substituents are? 1, 2, 3. 1, 2, 3. Two or more substituents in the main carbon compound. So here one carbon atom has two substituents. One carbon atom has only one substituents. So the carbon which has two substituents for single carbon atom must give the first priority. So lowest sum rule. If there are two or more substituents in the carbon compounds, the parent chain is numbered from the end, which gives the lowest sum of more substituents carbon atom. So, for example, if we give the number like this 1, 2, 3, 4, 5. So, which carbon atoms has substituents third carbon and fourth carbon. So third carbon 3 plus fourth carbon. How many substituents has fourth carbon? 2 substituents. 3 plus 4 plus 4. That is equal to 4 plus 4 8. 3 11. So the sum is 11. For if you give the numbering from right to left, 1, 2, 3, 4, 5. Which carbon atoms has substituents? 2 and 3. So sum 2 2 means second carbon. 2 in the sense second carbon. Second carbon has 2 substituents. So 2 plus 2. Then the third carbon also has 1 substituent. Plus 3. 2 plus 2 4. 4 plus 3 7. So we have to give the number from right to left, because when you give the number from right to left, the lowest sum rule is obeyed. Lowest sum rule is obeyed. So lowest sum rule is 7. Then if you count from right to left, lowest sum rule is 11. 11 from left to right, 7 from right to left. So we give the number from right to left, 1, 2, 3, because the carbon has more substituents will give the lowest number. Will give the lowest number part. This is lowest sum rule. Lowest sum rule. Then last one. Alphabetical order. Alphabetical order. When two or more different groups are present, such groups are arranged in alphabetical order. Alphabetical order. For example, here we take it CH3, CH2, CH2, CH. Bromine, CH2, Cl. CH2, Cl. Right. How many carbons? 1, 2, 3, 4. 1, 2, 3, 4. One more you have to take Cl. CH3. Here 1, 2, 3, 4, 5. 5 carbons. So how many substituents are there? 2 substituents are there. So in that two different functional groups, two different substituents are there. In this case, we need to follow alphabetical order. This is bromine. Br means bromine. Here Cl means chlorine. Which one will come according to our alphabetical order? Bromine. It gives bromine. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Realize carbon. Bromine is connected to third carbon. So 3 bromo. 3 bromo. Then 2 chloro. How many carbons? 1, 2, 3, 4, 5. Pentane. 3 bromo, 2 chloro, pentane. 3 bromo, 2 chloro, pentane. So like that, we need to give the name. Give the name. Because of it consists of, means we give the priority to alphabetical order. When two different functional groups are as substituents. For example, if it is as OH. If it has OH, then if it is has, for example, if it has COOH, it has OH. But prior is OIC hydras. So two different. Then according to the alphabetical order, we need to write. Here we take CH2 to Cl, two different. Hydroxy, this is hydroxy, this is chlorine, this is chlorine. So C, H. So we need to write first chloro, then after write hydrox. So these are the principles for nomenclature. These are the principles for nomenclature, right? So numbering carbon atoms, give from left to right or right to left, but then if there any substituents has any carbon atom has substituents, must give the minimum possible number. The functional group carbon should be given the lowest number. If the functional group is directly has in the main has carbon atom, then give the first group. If the carbon compound has functional group, but functional group has carbon directly, then give the first number. Then longest chain rule, then lowest number rule, lowest sum rule, alphabetical order. So this is about rules for nomenclature of organic compounds. Then write names for organic compounds, right? And we will write structure for the organic compounds also. So let's practice now. So the next session we will start.